Dr. Patrick Martone is a professor at the University of British Columbia and has been teaching the Ecological Adaptations of Seaweeds course as a part of the Bamfield Marine Sciences Center's fall program since 2010. I recently had the opportunity to ask him a few questions that have been on my mind since I was a student of his here at BMSC. Of all of the organisms in our ocean, why did you choose to study algae?
I get this question a lot. So the algae form a really important part of marine ecosystems. They make a habitat, they make food, for a lot of animals. And if we didn't have the algae, those marine ecosystems might collapse or change in really negative ways. When I started grad school, I was really interested in the evolution of shape and color and morphology of just biological organisms in the face of the environment. And when I discovered the seaweeds, here's this crazy group of organisms that have evolved multiple times, all kinds of shapes, sizes, colors, textures. You can stretch them in cool ways. It was just such a cool group to think about, and my mind exploded with ideas of different questions that I had. And I just felt like the seaweeds presented a really neat opportunity to ask fun questions about biology. In this era of ocean change, of global change, as the oceans are warming and as ocean pH is changing, there's a lot of researchers thinking about how these climate stressors are affecting seaweeds in particular. Because if we lose the seaweeds and we lose the habitat or we lose the food, that could have cascading impacts up the food web and through marine ecosystems. So don't neglect the algae. They form a very important part of our coastline.
Can you tell me a little bit about your tattoo?
Sure. So this is one of my favorite seaweeds. It's called erythrophyllum, and it looks like a big feather, and it's usually bright red and really beautiful, hangs off the rock in really wave-exposed areas. And I like it because I think of it as a hidden gem. Like when I find it, it just looks so amazing and different from all the other seaweeds. But I also like it as a tattoo because it really gets people's attention. People see what they want in this tattoo. I have plant people thinking it's a fern and they want to know what kind of fern I have. I have animal people thinking it's a feather, and so they want to know what bird this came from. And even seaweed people sometimes think it's a kelp, which is a very special kind of seaweed. And it looks like all of those things, and so I feel like it gets people thinking, and I love it when people ask me about it because it gives me a chance to really nerd out on how much I love this seaweed. So thanks for asking.
Why is algae important to the average terrestrial city dweller?
A lot of people don't realize that algae are already a part of our daily lives. If you brush your teeth in the morning, the toothpaste might have algae in it. The ice cream that you eat might have algae in it. Makeups that you use might have algae in it. So there are a lot of components of algae that are actually used in industry to thicken different products, to enhance different products. And so it's just kind of flying under the radar. People don't realize that algae are actually a part of your everyday life.
I've heard that some of your research work involves using various implements of algal torture. What are some of these instruments, and what are some of the weird things that you've done to seaweed?
There are two sides to that sort of algal torture, which is required. One of them is coming up with ways of generating really big waves or a lot of fast-moving water to measure how they interact with that water. So we have water cannons where we can, in my past, I've dropped water from the side of a building through some pipes in order to create wave crashes to measure how much force those little seaweeds experience. But we have recirculating water flumes, kind of like a tube of water that can race really, really quickly, and we can put kelps in there and measure how much force they experience. But the other side of the equation is how do they resist those forces? So we have what kind of look like torture racks where we rip seaweeds apart to measure their material properties, and that tells us how strong their tissues are, how far they stretch, and then we've done all this chemistry to figure out, what are they made of that gives them these crazy properties, because one of the lessons that we've learned from algae is that you have to be able to be flexible in order to basically flop around to reduce how much drag you experience from the water flow, and also to stretch under the water and not break.
What kind of personal significance does the Bamfield Marine Sciences Center and the fall program here have for you?
Well, I have now been teaching in the fall program at Bamfield for about 10 years, and it's one of my favorite times of year when I get to come out here and hang out with a bunch of really keen students who are excited about marine biology. And one of the things that I often reflect upon is that, so I teach at UBC, and I teach a big algae class at UBC, and I get people excited about algae in the classroom, but it's very, very different when I can be out in a boat or on the beach or on the shore with students and point out all of these organisms that they've never paid attention to before. Very few people come to Bamfield thinking about seaweeds in particular. They usually have other organisms in mind that they're most excited about. And so for me, it's extremely satisfying to blow their minds with fun facts about seaweeds that they've never thought about. So for me, teaching seaweeds at BMSC is one of the high points of my career through UBC.
Do you have any advice for folks who are interested in learning more about algae, either academically or out of personal interest?
I think if you're a student and you're interested in learning more about algae, take an algae class, find any course that talks about seaweeds or algae, and I think that'll be a good starting point. I think if you're interested in grad school and thinking about a master's or a PhD, look around for professors who study algae one way or another. Lots of ecologists are thinking about algae these days, and see if they have availability. I think a lot of other people don't fall into those two camps. They're just interested in seaweeds that are living on the coast. They're avid beachcombers. And I'll give you a couple ideas. One is that I've developed this app called the Seaweed Sorter, which is for your phone, so that you can take it out in the field with you, and when you're walking on the beach, it allows you to identify over 100 species from our coast. I actually developed it here at BMSC, or partly at BMSC, with the help of lots of students, because we're always out on the shore collecting seaweeds, figuring out what we're looking at, and I took a lot of that information and got input from the students about what is the best way for people to tell this seaweed apart from the others. So that's been a really fun activity over the last few years, is getting this app working. And another option is just, there are lots of books out there that talk about marine biology, and find one that has a really good algae section, and you might learn about their ecology and their diversity, and that might also help you on your trips to the coast.